This is section 6-4, analyzing graphs of polynomial functions. Our objective today is I can graph a polynomial function, locate zeros of a function, and estimate the x-coordinates for which the relative maxima and minima occur. Let's go ahead and take a look at example 1. We're looking at the graph of a polynomial function. And it says to graph f of x equals negative x to the fourth plus x cubed plus 3x squared plus 2x by making a table of values. So I went ahead and I made a table of values that you guys can get copied down. And I chose several x values because in order to really see what's going on with these, we're going to need lots of x values. It's not like a quadratic function that we know when it starts going up, it's going to go up forever. There could be some different things going on with this. Now, with the x values that I have, I need to be able to come up with those f of x values or the y values. And I'm just going to do one example of how we get that. So to get f of x, we're just going to plug in whatever x value there is. So our first x value that we're using is negative 2.5. So instead of x, we want to actually use the negative 2.5. So we're going to have f of negative 2.5, and then our f of x was negative x to the fourth plus x cubed plus 3x squared plus 2x. So anywhere there was an x, here, 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 and here, we are plugging in negative 2.5 now. So we have negative parentheses negative 2.5 to the power of 4. Make sure you always put what you're plugging in parentheses, or it will not come out correct. Parentheses, negative 2.5 cubed plus 3 times negative 2.5 cubed plus 2 times negative 2.5. Okay, so that's pretty lengthy, but when we evaluate that all the way through, we're going to end up getting negative 41. Evaluating the rest of these, we're going to get negative 16 for negative 2. At negative 1.5, we're going to get negative 4.7. At negative 1, we're going to end up getting negative 1. At negative 0.5, we're going to get negative 0.4. At 0, we're going to get 0. At 0.5, we're going to get 1.8. At 1.5, we're going to get 8.1. At 1. At 1, we're actually going to get, sorry about that, at 1, we're going to get 5.0. At 1.5, we're going to get 8.1. At 2, we're going to get 8.0. At 2.5, we're going to get 0.3. And at 3.0, we're going to get negative 21. Okay, so let's go ahead and graph these. So if we're looking at these, we have negative 2.5, negative 41. So if I'm looking to graph this, I'm going to go over to negative 2.5 area, and then negative 41 is going to be way off my graph, so I'm not going to be able to graph that one. With negative 2, negative 16, that one's also going to be off my graph, so I can't graph that either. But negative 1.5, I can graph that. Negative 1.5, and then down to negative 4.7. It's going to be about right there. And then we have negative 1, negative 1, which is going to be in this area. I'm going to darken these. Okay? And then We have negative 0.5, negative 0.4, which is going to be about right there, right next to where we already have our dot. And then we're going to have 0, 0, and 0.5, 1.8, and 1 and 5. And 1.5, 8.1, and then 2 up to 8, and 2.5 up to 0.3, and yours will look more accurate than mine since you'll be doing this on paper. So now we can go ahead and draw our line to go with this. So we know that he's going to be going way down to here and through 0, 0, all the way up, and then he's going back down. So we want to draw arrows on these. And now I have a decent sketch of what our graph is going to look like. And we know that this is an even degree polynomial with the negative leading coefficient, so f of x is going to approach negative infinity as x is approaching negative infinity, and that's what we looked at in section 6.3. And that is f of x is approaching negative infinity, x is going to positive infinity. And we can notice that this graph intersects the x-axis at 2 different points. So it's here at 0, 0, and then right here we don't have an exact point, but we know it's crossing in 2 locations. And so we know that there's going to be 2 zeros for this function. So example 2 says to determine consecutive integer values of x between which each real 0 of f of x equals x cubed minus 4x squared plus 3x plus 1 is located, and to draw the graph. So let's go ahead, we're going to do the same thing we did in the first one, and we're going to evaluate this. So I went ahead and made a t-chart, and these values that we're going to get, we're going to be filling these in over here. So if we go to fill this in, remember we're just plugging the number, the x value, in for the x. So for the first example, I'll write it down here for you guys. We have negative 2 to the third power minus 4 times negative 2 squared plus 3 times negative 2 plus 1. Remember, we want what we're plugging in, we want to keep it in parentheses. So if we fill in our f of x values, we're going to end up with negative 29 for negative 2. Negative 1 is going to give us negative 7. 0 will give us 1. 1 will give us 1. 2 will give us negative 1. 3 will give us 1. And 4 will give us 13. And this is going to actually help us to be able to determine what's going on because we can see where there's a change in sign. So from negative 7 to 1, there's a change in sign, which means it's going to have to cross this x-axis somewhere because we went from negative values down here up to positive values. So I'm just going to go ahead and mark these. So we know from negative 7 to 1, there's a change in sign. And then we also know that from 1 to negative 1, there's a change in sign. And then also from this negative 1 to this positive 1, there's a change in sign. So that's indicating that there's going to be 3 zeros that we're trying to find. So if we look at those values, we could go ahead and we can sketch what the graph is going to look like. So let's go ahead and do that. So we have negative 2, negative 29, which is going to be way off of our chart, but we do have negative 1, negative 7 that we can graph. It's about right there. And then we have 0, 1 we can graph. And then we have 1, 1 we can graph. And then we have 2, -1 we can graph, and 3, 1, and 4, 13, which is also going to be off of our graph somewhere up in this area. But we can go ahead and graph our line. And we want to graph based off of the order that we put those. So we want to go from the first point that we made all the way to the second point, and then to the third point, and so on, all the way up to our last point that we made. Okay, so we can see approximately where this is going to be crossing, and so that's what the question's asking us. They want us to tell where is the change occurring. So our first 0, which is right here, is going to be located between -1 and 0. So that's what we want to write. Between -1 and 0 is our first one. Our second 0, so the second place it's crossing the x-axis is right here. And that's going to be between 1 and 2. And then we still have a third point that we're looking at right here, and that's actually going to be between 2 and 3. So approximately, those are where our zeros are going to be. Alright, and then we're looking at example 3. It says to graph f of x equals x cubed minus 4x squared minus 2x plus 3 and to estimate the x coordinates at which the relative maxima and relative minima occur. Okay, so same deal with this. Created a table of values, and I'll show you guys how we're going to plug those in. I'm actually going to start at the bottom this time. You can always start with the top. I'm just starting with the bottom to change it up a little bit. So we have 5 cubed minus 4 times 5 squared minus 2 times 5 plus 3. So remember, all we're doing is looking at these x values up here. There's 3 x values, and we plugged in our 5 for each of those values. And you're going to do that with every single value of x to get the f of x values. So now we can go ahead and fill these in. For our 5, we're going to get 18. For our 4, we're going to get -4. For the 3, we're going to get -12. For 2, we're going to get -9. For 1, we're going to get -2. For 0, we're going to get 3. For -1, we're going to get 0. And for -2, we're going to get -17. So now we need to go ahead and see what's going on with this. So let's go ahead and graph it. So -2, -17 is going to be off of our chart, but we can graph a lot of the other ones. So we have -1, 0 as a point. We have 0, 3 as a point. We have 1, -2 as a point. We have 2, -9 as a point. We have 3, -12, which is going to be somewhere off of our graph. Somewhere down here. We have 4, -4. And we have 5 all the way up to 18, which is way up off of our graph. So now we can go ahead and graph these. Okay, so the value of f of x changes signs between x equals 4 and x equals 5. So here we have -4 and here we have +18, indicating a 0 of the function. So we know there's going to be a 0 between those values. So this is what we're talking about. the value of f of x at x equals 0 is greater than the surrounding points, so there must be a relative maxima near x equals 0. Now that doesn't mean that that's necessarily going to be the maxima, that just means it's going to be near it. And then we also know that the value of f of x at x equals 3, so we had f of x is negative 12, is less than the surrounding point, so there must be a relative minima near x equals 3. So let's go ahead and write that down. So we're going to say that there's a relative max at x equals 0, and that there's a relative minimum at x equals 3. So your homework that I want you to complete on this, you've got a couple of check your progress questions. I think there's only 2 of them, a number 1 and a number 2 on your note sheet. I'll have you do those on a separate sheet of paper. And I'm also going to add one more problem, and I'll put that under the assignment section on Canvas.